Good day, grade 12 students. This is Physical Science Quarter 4, Week 1 by your teacher here, Miss Diane Grace Lee. Our lesson's objective is explain how the Greeks knew that the earth is spherical. Before we start, please prepare your module and writing materials. Alright, let's begin. Now, I want you to turn your module to page 3. Let's sing the song The Shape of the Earth is Round in the tune of The Wheel of the Bus Go Round and Round by Xandy B. Fagliarno. Are you ready to sing? Let's sing! The shape of the earth is round, just round, round, just round, round, just round. The shape of the earth is round, just round, all this time. The Greek philosophers had thought it's flat. Some thought it's round, some thought it's round. The Greek philosophers had thought it's flat, but they got it wrong. North Star eclipse and sailing ship, Moon's shadow from Earth's relationship. This conclude that the earth is round all this time. I hope you learn and enjoy the song. Around 500 BC, most Greeks believed that the earth was round, not flat. It was Pythagoras and his pupils who were first to propose a spherical earth. In 500 to 430 BC, Anaxagoras further supported Pythagoras' proposal through his observations of the shadow that the earth cast on the moon during a lunar eclipse. He observed that during a lunar eclipse, the earth's shadow was reflected on the moon's surface. The shadow reflected was circular. Around 340 BC, Aristotle listed several arguments for a spherical earth, which included the positions of the North Star, the shape of the moon and the sun, and the disappearance of the ships when they sail over the horizon. The North Star was believed to be at a fixed position in the sky. However, when the Greeks traveled to places near the equator like Egypt, they noticed that the North Star is closer to the horizon. Aristotle argued that if the moon and the sun were both spherical, then perhaps the earth was also spherical. If the earth was flat, then a ship traveling away from an observer should become smaller and smaller until it disappeared. However, the Greeks observed that the ship became smaller and then its hull disappeared first before the sail, as if it was being enveloped by the water until it completely disappeared. The first successful attempt to determine the size of the earth was made by Eratosthenes. He did this by applying geometric principles. He observed that the angles of the noonday sun into Egyptian cities that were almost opposite each other, Syene in the south and Alexandria in the north. He assumed they were in the same longitude. Anaxagoras was able to explain what causes the phases of the moon. According to him, the moon shone only by reflected sunlight. Since it is a sphere, only half of it illuminated at a time. This illuminated part that is visible from the earth changes periodically. Eudoxus proposed a system of fixed spheres. He believed that the sun, the moon, the 5 known planets, and the stars were attached to these spheres, which carried the heavenly bodies while they revolved around the stationary earth. Aristotle was a student of Plato. For him, the earth is spherical in shape since it always casts a curved shadow when it eclipses the moon. He also believed that the Earth was the center of the universe. The planets and the stars were concentric crystalline spheres centered on the Earth. Aristarchus is the very first Greek to profess the heliocentric view. The word helios means sun, centric means centered. This heliocentric view considered the sun as the center of the universe. He learned that the sun was many times farther than the moon and that it was much larger than the earth. He also made an attempt to calculate the distance of the sun and the moon by using geometric principles. He based his calculations on his estimated diameters of the earth and the moon, and expressed distance in terms of diameter. However, the measurements he got were very small and there were a lot of observational errors. Hipparchus is considered as the greatest of the early Greek astronomers. He observed and compared the brightness of 850 stars and arranged them into order of brightness or magnitude. He also developed a method for predicting the times of lunar eclipses to within a few hours. Aside from this, he also measured the length of the year to within minutes of the modern value. Ptolemy believed that the Earth was the center of the universe. His Ptolemaic model claimed that the planets move in a complicated system of circles. This geocentric model also became known as the Ptolemaic model. According to the Ptolemaic model, the Sun, the Moon, and the other planets move in circular orbits around the Earth. However, if observed night after night, these planets move slightly eastward among the stars. At a certain point, the planet appears to stop, then moves in the opposite direction for some time, after which it will resume its eastward motion. This westward drift of the planets is called retrograde motion. To justify his Earth-centered model using retrograde motion, he further explained that the planets orbited on small circles called epicycles, revolving around large circles called deferents. Now, let's listen to Aristotle's conclusion that the Earth is round.
Firstly, I considered the position of the North Star. The farther north you journeyed, the closer the North Star seemed to move to the middle of the sky. But if someone were to travel south of what we now call the equator, the North Star could not be seen at all. I also watched ships sailing into port. I noticed that at a distance, I could see the tops of their sails before I see the rest of the ship. I deduced that this was because of the curvature of the Earth. And lastly, I observed the shadow cast during eclipses.
That's it for our lesson. I hope you learned something new today. But before we end, please answer the assessment on your module on page 4-5. This ends our lesson. See you in the next video. Thank you for watching.